Now this time we're going to find Jupiter. Now this is what's called the ecliptic line. In other words, that's the orbits around the solar system, and this is north-south, which is fine. However, when we look at it with a video camera, we find that this is on, there it is, I'll just bring it back to the 17th. There's the 17th of June 2 BC. Here it says 1 minus 1, but which is actually 2 BC. And we can shift the hours, and you'll see this turning. Now, the computer software programmers have linked this, assuming that to be up north-south at all times. This may be a common mistake in astronomy. If you look at it every day at the same time, it'll be the same position. But if you watch it over a period of 24 hours, you'll find it'll flick back and forwards, which we will do for you right now. But we'll zoom in a bit before we do that. So you watch the stars on the outside here, which are the moons. There's 1, 2, 3, 4, 5 moons. This is ecliptic, so therefore that is north-south. So we now animate it. That's what it shouldn't be doing. So it's still the same date. It's now 10:44. We'll do it some more. 11. Let 12, and then start coming back. And when it comes back, we see there's Jupiter coming in. That's the alignment between Jupiter and Venus on the 17th of June 2 BC, Sydney, Australia. Now, if we go to Christchurch, New Zealand, this is on the international dateline. Christchurch, New Zealand, there it is. We see that it is coming, it's ahead because it's already happened, it's moved away. So we'll move it back. And that's the perfect and closest position compared to right now, it's there. So we set the date again, back to where we was, same location. Do that simply by doing 0 minus 1. This here, go forward. 6 minus 1. We go to the day we want. There's the 17th. We go to the hour we want, which is 13. And 47 seconds. We'll see the band here, and the moon is encroaching on the band, which was missing some weeks ago. Now it's back, the red eye was still there. So now we're going to go to another location, and it's rather stunning. It goes to where I was born. Click on that. It's now done. It says moved up slightly. I did get it to work probably. Now, what we have then is a figure 8. So we have the 8 in Jupiter and Venus above New Zealand on the 17th of June 2 BC, and The reason for that is first past the international date line, but it's also New Zealand lay between 888 miles apart, measuring latitude to latitude in a straight line north-south. So this is Sydney. So the better eclipse occurred, or conjunction occurred, in Christchurch than to Sydney, predicting the birth. And then we go to a new location. In this case, it's Bethlehem. You can also click on it like so. And what you have then is when it occurred in Bethlehem, we've got to locate Jupiter. There it is there. Then we'll start going forward in time. So there we have an eclipse or conjunction of 1353, and you'll see there is a space between the two. So it's possible to measure these distances to give us an accurate information. All is a message. So we'll just leave it there. We'll run this fast. You'll see this turning around. Get that out of the way. Well, we'll bring it a bit. And you'll see that when we run it, it's going to bobble back and forwards. Remember, this is remaining, that line should be remaining there, but they fixed it. They just didn't realise that these planets do revolve around its axis and across the 90 degree of its axis. So, here we go. There goes Venus, and then it's flopping back and forth like that. Now we notice this time that the planet Jupiter has the red spot and it's on the south side, so it's the right way up, at least when it is running along the ecliptic. However, we go to today's date and we'll watch what happens. It's closer, and it's revolving around the correct position.